Good morning, all. I am Mansa. Currently, I am pursuing my final year BTech in the stream of Triply from Annamacharya Institute of Technology and Sciences, Rajampet. Today, I am here to give a presentation on our project Battery Monitoring and Control System for Electric Vehicle using IoT technology. And my teammates are Narsimha, Ram Mohan, and Venkat Srinath Reddy. We have done this project under the guidance of Dr. S. Venkateshwar Reddy, sir, Assistant Professor of Triply Department. Coming to the outline of the project, it includes introduction, motivation, literature survey, problem identification, proposed methodology, objectives, block diagram, advantages, applications, results, conclusion, future scope and references. Introduction. Electric vehicles are the groundbreaking innovation in the transportation industry because of its merits like no fuel, less pollution and more efficient working. And as a battery is the heart of the electric vehicle. So we are revolutionizing the way to monitor and control the battery. And the motivation. The primary incentive of this project is to develop a real-time system for monitoring and control of the battery parameter so that it helps in increasing the safety, efficiency and lifetime of the battery. Literature survey. We have done a thorough literature to understand the current state of the research in this field so that it helps in our exploring and shaping our methodology. And here I am presenting the summary of our findings and discussing how our research contribute to this. First one is the EVBMS with charge monitor and fire detection proposed by Y. Mastanamma et al. Here they suggested an integrated approach for the electric vehicle battery management. It includes the battery management system, charge monitoring and fire detection. Here they monitor the key parameters of the battery. And second one, IoT based battery monitoring system for the electric vehicle proposed by Lakshmi Sri et al. In this system, they used the IoT technology to monitor the battery parameters like voltage, current, and the temperature, and it also sends the message to the user. In this project, only it monitors the parameter of the battery, and controlling actions are limited. And third one, IoT based electric vehicle application using boosting algorithm for smart cities proposed by Manoharan et al. And here they integrated the IoT technology in the electric vehicle for efficient monitoring of the battery, and they also used the ThinkSpeak platform for and a boosting algorithm. Drawbacks of these are the data security, privacy concerns, and the reliability of IoT connectivity. And summarizing of these three, or in all these three, they are concerned with the monitoring of the battery parameters or battery management system. Controlling actions are very limited, so we are focusing on the controlling actions too, along with the monitoring activity. Problem identification. From the extensive literature available in all the existed methods, they have developed different battery parameters monitoring. Even in all the methods, the monitoring of the device is mostly concerned and controlling actions are very limited. So we are revolutionizing the way to monitor and control the both monitor and control the parameters of the battery. And we also integrate the voltage and temperature monitoring with an automatic cutoff using the IoT technology. And we also send the information to the user through an Android app. Proposed methodology. In this system, we have used the different sensors, Node MCU, LCD, and then cloud connectivity that facilitates the remote monitoring through an Android app. So different sensors like voltage sensor, temperature and humidity sensor to monitor and control the battery conditions, and they provide the real-time monitoring data to the user. And analog output from these sensors are converted to the digital using the Node MCU, that is ESP8266 microcontroller with 32 bit pins, and the data is sent to the cloud, and cloud connects the data to the uh, user through an Android app. And requirements are these hardware components are Node MCU, voltage sensor, temperature and humidity sensor, LCD module, motor driver, motor and a battery. Node MCU. Node MCU is an low cost open source IoT platform which can be used as a microcontroller, and the ESP8266 is the microcontroller. The purpose of Node MCU in our project is to collect the data from the different sensors, process the data, and sends that information to the cloud, which after sends the information to the user. And the voltage sensor, it measures the voltage across the battery. Temperature and humidity sensor, THT11 is the temperature and humidity sensor we have used here. It also measures the temperature and humidity of the battery and sends the information to the user node MCU, and we have used the LCD 16 by 2 display for displaying the parameters of the battery to the user, and a DC motor to drive the wheels of the vehicle, and a motor driver. A motor driver is used to allow motor to drive in either direction, and we can control the driving action of the motor using a motor driver. And the objectives of our project, it main objectives are to monitor the voltage and temperature across the battery, humidity across the battery, and fire sensing and automatic cutoff of the battery, and the data is read in the mobile phone that through an Android app. Here it represents the block diagram of our project. It includes the different sensors, relay modules, motor driver, motor, LCD display, and power supply unit, and finally the IoT. Advantages of our project are real-time monitoring, remote accessibility, early warning system, optimized maintenance, enhanced safety, extended battery life, energy efficiency optimization, and application. We can use this in the personal electric vehicle, ride sharing services, energy grid integration also. And here are the results that here it represents the circuit connection of the proposed battery system, and here are the displaying of the battery voltage, temperature, humidity, and fire sensing on the LCD display. Here is the user interface that display the values to the user through an Android.
Here it is the prototype of battery monitoring and controlling of electric vehicle using IoT technology. The main components of motor driver, microcontroller, buzzer, battery, temperature and humidity sensor, buck converter, LCD display. The main function of motor driver is it drives the motors at a time. This is microcontroller with a type of ESP8266. It has a 16 digital pins, one analog pin. It to process the signals which collected from the sensors. It sends the data to the cloud. This is a LCD battery, 12 volts lead acid battery. This is temperature and humidity sensor. It sends the temperature and humidity of the battery. LCD display, the main function of LCD display is it displays the temperature, humidity of the battery. This is buzzer. The buzzer gives the alarm sound when the battery parameters are not within the limits.
And in conclusion, electric vehicles are the groundbreaking innovation in the transportation industry. Here, in this proposed method, they have extensively covered the sensor-based technologies. And here in this system, when the battery parameter exceeds its range, we get an the user get an buzzing sound, and the vehicle will be automatically cut off, so that it prevents the battery exploitation and firing hazards, and the life of the battery will be improved. Coming to the future scope, in the future research, we can use the different advanced algorithm for data analysis and the maintenance of the battery, and we can integrate the monitoring system with the smart grid too. And these are the references. Thank you all.